Assalamualaikum warahmatullahi taala wabarakatuh. Hi everyone, sorry for the very late video on topic 5 because I was actually waiting for my stylus pen. It's really been taking really a long time for the pen um, to be posted to my address, so that's why the video will be really delayed, but I'll try to catch up, and I hope you also can catch up as well, because actually topic 5 is so much related to the topic 4, in which that you have to design reactors for single reaction. It's just that in this topic we'll be dealing with multiple reactors. So last time we have single reactions. So for example, you have A to produce B, and maybe this chemical equation or this reaction of A producing B will take place in only in a single reaction, let's say only in PFR, or maybe only in the MFR or CSTR. Okay, but for this topic, in topic 5, we have single reaction, which is, for example, this chemical equation of A producing B, maybe will be taking place in multiple reactors. For example, maybe this chemical equation or this chemical reaction will be taking place in series of CSTR, for example, maybe 1, maybe 2, maybe 3. Okay, so the same chemical reaction is taking place in these 3 reactors, for example, or maybe not only, maybe another single reaction, let's say A producing C will be taking place in, for example, first PFR, and then it goes into CSTR, for example, maybe PFR again. So it depends. Okay, so we'll be looking at this kind arrangements of reactors in multiple series. Okay, let's get started to the next slide. Okay, sorry. Before we go that, you still need to recall you need to recall on the design equation, for example, for batch. So you have to remember, you have to bear in mind, okay, this is the design equation for batch. Design equation or mole balance is the same thing. So yang ini adalah untuk CSTR, yang ini untuk PFR, whereby this one is for PBR. So kalau PBR, they just change, instead of volume, they will use this weight of catalyst. Okay. Jadi, for this topic, again, this topic is dealing with chemical reaction, a single chemical reaction which taking place in multiple reactors. So kita akan tengok different multiple reactors. It's either PFR in series ataupun MFR in series, MFR or CSTR, okay? So ataupun kita boleh tengok CSTR or MFR in parallel. Okay. Ataupun there will be a situation where there will be a combination, either PFR with MFR ataupun MFR dulu kemudian PFR. So kita akan tengok this combination of reactors. We will look at we will design again, still related to design. Kita akan tengok macam mana the calculation for conversion, how is the calculation for volume. Okay, provided that dia akan beri concentration, volumetric, etc. lah. Okay, so we'll be looking at all these things. Again, kalau kita tengok the combination of these reactors, kita akan kira berapa dia punya conversion, berapa dia punya volume, etc. Okay, so that's a little bit overview on this topic. Okay, so let's get started. For example, we start with PFR in series first. Okay, katalah you have chemical reaction of A plus B producing C, for example. And this is with regard to a single reaction. And this single reaction is going to be taken place in these three PFR. Okay, ini kita panggil first PFR, R1, reactor 2 of PFR, reactor 3 of PFR. Jadi let's say that A is the limiting reactant. So the flow rate initial of A adalah FA0 with initial conversion X0. So X0 kalau initial selalunya adalah kosong. So the reactant of A bila masuk in this first reactor of PFR, so will be reacted. And bila dia reacted, of course still ada flow yang keluar of reactant A which is not properly converted, so dia akan keluar. So berlakunya X1 lah dekat sini. Okay, kemudian the FA1 will going through reactor 2, so berlaku lagi reaction. And bila berlaku reaction, ada reactant yang still not completely converted, and kita namakan dia FA2, which is remaining reactants. And X2 is actually represent the conversion of R2 and R1. Okay, please bear in mind on that. Jadi FA2 yang the unconverted one will be going through the third reactor of PFR. So berlaku reaction dekat dalam third reactor. So of course akan ada lagi remaining reactant which is not completely converted. So kita panggil dia FA3. And X3 will be the conversion that represents the whole reactors, which is reactor 1, reactor 2 and reactor 3. So untuk ini we are going to have a look how does the design looks like for these reactors of PFR in series. So katalah tadi kita ada first reactor FA0 tadi masuk dalam PFR yang pertama. Okay, so dia akan keluar FA1 with X1. So meaning that the volume for R1 is, so kita boleh cakap X0 X1 FA0 negative RA dx. So PFR punya design equation, you have to bear in mind that dia macam ni kan. X0 X1. So teruk betul. Kena ingat design equation untuk PFR. PFR. FA0 over negative RA X0 X1 dx. So kalau untuk first volume akan berlaku conversion yang keluar daripada first reactor S to B X1 kan. So daripada initial conversion kepada X1. So this is the first reactor. So kalau second reactor, dia akan masuk ke second reactor. So yang keluar FA2 X2 is the conversion that represents conversion that happens in R1 and R2. Jadi untuk volume R2 is gonna be daripada X1 kepada X2 Okay, ini cara kira untuk volume yang kedua. How about the third volume? So kalau third volume, saya tak ada tempat pula. Let's say that okay, third volume. So dia dari FA2 masuk ke dalam R3, keluar adalah FA3 and the conversion is X3, which is from X2 here. Therefore, the volume for PFR yang ketiga adalah X2 kepada X3 FA0 negative RA dx. Okay. So if let's say in order to calculate the whole volume from volume first reactor to third reactor, so you have just to calculate V1, V2, V3. Okay, V1 plus V2 plus V3, VR1 plus VR2 plus VR3 is the volume total, in which bila you buat volume total V1 plus V2 plus V3, this is the same as yang tadi you buat X0, X1, FA0 over negative RA dx plus, so kat sini X1, X2, lepas tu you tambah lagi kat sini X2, X3, FA0 over negative RA, etc, etc, which is, if you combine this, it's actually the same as X0 kepada X3 FA0 over negative RA dx. Okay, so itu cara nak kira the whole volume apa tu, reactor lah, untuk PFR, yang bermaksud juga saya padam sikit sebab nak tunjuk. Okay, yang bermaksud PFR 1, lepas tu pergi ke PFR 2, PFR 3, yang mana you buat VR 1 tadi, you kira VR 2, VR 3, in which yang ini sama juga dengan X0 sama dengan ke X3 FA0 over negative RA dx, in which this is the same as if you just make it into one whole PFR. It's the same, cuma you akan jimat instead of installing all those piping. So just buat the whole long PFR with of the volume of VR1 plus VR2 or plus VR3 sebab mendapat conversion yang sama. So tapi the advantage is you just omit all those pipings. Okay. Okay, itu adalah cara kiraan volumenya. So if you actually looking at looking at the graph, which is under the curve. So inilah grafnya. Okay, katalah ini FA0 over negative RA and this is X. So let's say that you have 3 reactors just now. So you ada X1, ada X2, ada X3. So bila you plot, so the volume under the curve is representing the volume of PFR. Single PFR yang panjang tadi adalah bersamaan dengan 3 reaktor ni. Okay. So next is we move to MFR in series. I think I have to stop here. We continue to the next video.